Hello and welcome everybody to this video on linearization. This is definitely not the world's most interesting topic as far as AP Calculus is concerned. However, it's one of those necessary evils. The upshot is it's actually really simple because all we really have to know is the equation of the tangent line, which I have written right here in red. Um, let's remember, that the slope here is going to be the first derivative of our function evaluated at x equal whatever the a value is. Okay, so anytime you're asked to do a linearization problem or a linear approximation problem, they're the same thing. We will always need the information for the derivative because that is the slope. So slope or derivative information, same thing there. We're always going to have some x value to center our approximation around. And then we're always going to use that to approximate something else. Okay, so those are the characteristics of a linearization problem. Once again, the derivative, a an x value to center, and something to approximate. Okay, so let's jump right in. We need the slope here. We need m, and m is just going to be the first derivative of this. So dy dx, we are going to take the derivative of this. So we're going to do 1 minus x to the 1 half, and then we are taking the derivative of that. So we're going to put a prime on that. Okay, and chain rule, right? It's all about the chain rule. 1 half, leave the inside the same, reduce the power by 1, multiply by the derivative of the inside. Derivative of 1 is 0. Derivative of negative x is negative 1. Simplify if possible. This is going to be negative 1 over 2, and then negative exponent there, square root 1 minus x. Okay, so boom, there we go there. And now we just need to plug in. Okay, well, what are we asked to approximate, right? Let's get that straight away. We are asked to approximate the square root of 0.9. Okay. So all right, let's okay. We have our slope here. We need this. Let's back up for a second. Here a equals 0. So let us use that. That's basically x1. Okay. So x1 equals a equals 0. So therefore y1 is going to equal the square root of 1 minus x1, which is going to be the square root of 1 minus 0. And of course, that's just going to be 1. All right, so now we have x1, we have y1, and x1 is going to be what, yeah, x1 is going to be what goes in here. I'm messing that up there. Okay, so again, x1 is going to be 0, so the slope at x1 equals 0 is going to be negative 1 over 2 square root of 1 minus 0. Okay, so that gives me negative 1 half altogether. Okay, there we go. And so here we are. Y minus 1 equals negative 1 half x minus, and then x1, of course, is just 0. So this is our linear approximation. So let me just simplify here. Y minus 1 equals negative x over 2. Whew, sorry about that. If I solve for y, y is going to be, if I add 1 to both sides, I'm going to have a positive 1 and then minus x over 2 after that. All right. Okay. So we have all the tools in place. We still have not got the final result. We need to be careful and we need to think about what x has to be. Okay. So, so we want to approximate the square root of 0.9. So let's think about what x has to be in our function to give us 0.9. That's got to be the square root of 1 minus what gives us 0.9. That's how we think about this. This is going to be 1 minus 0.1. Okay, so in other words, x equals 0.1 in order to get that. So we are going to evaluate this at x equals 0.1. Okay? And we get 1 minus 0.1 divided by 2. And what is 0.1 divided by 2? That is, well, that's going to be 1 minus, and then 0.1 is 1 over 10. And then it's basically times 1/2, right? So it's 1 minus 1 over 20. And if we do a common denominator and all that, we're going to get 20 minus 1 over 20, and that's going to give us 19 over 20 as an approximation for the square root of 0.9. Okay, and then if that, if that was not too good, we're going to do it one more time for 0.99. Now, once again, we're just going to look at the function that we have, and we're going to think about what x has to be to produce this value here, okay? So 1 minus what is 0.99, right? And you can even just solve this equation and figure out what x has to be, right? So let's do that. Let's add x to both sides. Let's subtract 0.99 from both sides. If we do that, we're going to get x equals, and then 1 minus 0.99 is going to be 0.001. Okay, so that's going to be the x value for this part of the problem. So we're just going to plug that in here. 1 minus 0.001 over 2, and of course this is I messed that up. You know what? I think it's 0.01. I put an extra 0 there. 0.01. Sorry about that, everybody. 1 minus 0.01 divided by 2, and that's going to give us 2 minus, and then this is going to be 1 over 200, right? Because this is 1 over 100 and then times 2. 200 times 2 is going to be 400 minus 1 over 200. That's over 200. Yeah, okay, I guess so. Something's weird here. 400 minus 200 is 300. Very strange. Something went wrong here. What did I do? Okay. 1 minus 0.01 divided by 2. Nothing wrong with that. Now this is a tiny, tiny number, so there's no way it's gonna. Okay, so somewhere I messed up. 0.01. That is literally 1 over 100. Yeah, 2 minus 1 over 200. Oh boy. Oh, oh, I made this a 2. That's the problem. Okay, that doesn't need to be a 2. 1 minus this. Sorry about that, everybody. So this is going to be 200 minus 1 over 200, and that's going to give us 199 over 200. Sorry about the little arithmetic mistake there. Sorry about the x's, but there we go. 199 over 200, and this is going to be the linear approximation to the square root of 0.99. Okay. So yeah, and then the graphing stuff. We'll look at the graphing stuff in class. So I'm gonna call it for this video. See you